Hello guys, this is the example number 1 of open flow channel. So the water depth upstream of a sluice gate is 0.8 meter and the depth just downstream at the vena contracta is 0.2 meter. So calculate A, the discharge per unit width, and letter B, the flow numbers upstream and the downstream. So the given H, the head 1 is 0.8 and the head 2 is 0.2. So assuming that head the same on the other side of the gate, so Z is 1 plus V1 squared over 2G is equals to ZS2 squared plus V2 squared over 2G. Substituting the ZS to H and the V is equals to Q over H. So H1 plus Q squared over 2G H squared over 1 and is equals to H2 plus the Q squared over 2GH squared over 2. So you know the difference right now. So the ZS here is substitute by H, so H and H here. So from the given data in meter second units, 0.8 H1 plus 0.0796 Q squared over 0.2 plus 1.2742 Q squared. So 0.6 is equals to 1.1946 Q squared and the Q is equals to 0.7087 meter squared S over negative 1. So the answer of letter A is discharge. The discharge per unit width is equals to 0.709 meter squared as negative 1. So the continuation of the letter B, the flow number upstream and the downstream. So the use on each side of the gate. So the V is equals to Q over H and the FR, the flow, is V as equal over to square root of GH. To get the V1, how do we came up this answer? So we use this formula, the V over QH. So the V1 over I equals to Q over H. The V1 is equals to the answer of the QH. We get it from the first solution. Here the Q is equals to 0.7087. So that's why we came up this value of the Q, and the H here is in the H1, so 0.8. So 0.8, so you divide it, 0.7087 is equals to I over 0.8. The answer is 0.885875. So now here the V2 is the same, so the H is the H2 rather is here, H2, and divide it, we came up this answer. So that's why this is the V1 and the V2 here. And how do we get the fraud one? You can use this formula. So that's why the fraud 1 is equals to 0.3162 and the fraud 2 is 2.530. So the fraud number upstream, the upstream here is the fraud 1, is the 0.3162, and the fraud 2 or the downstream is 2.530. So 2.53 rather. So that's it, and thank you guys. So guys, this is the another example, trapezoidal. So the giving in here is the Q is equals to 63.50 feet cube per seconds, and the N, the roughness, is 0.011 and the slope is 0.012 feet per feet. So find the hydraulic depth. Letter B, the velocity, and the C is the classify the flow. So A, so the hydraulic depth, the D is equals to area over the total depth. So how do we get the 10 plus 12 plus 5 here? So if I know that the depth here is 5, so the triangle here says that 1 over 2, so 5 times 2, so 10 feet. And if the 5 here, if I know the depth here is 5 and 5 here, and the triangle says that 1 over 1, so this is 5 feet also. So how do I get this? Also 10 plus 12 plus 5, so 10 plus 12 plus 5 is equals to 27. So how do I get the area here? So we know that the height here is 7.2, and then the total depth here is 27, so we multiply here, multiply it and subtract it by, how do we get that negative 20 minus 25 here? So what's this, 2 times 5 times 10, 50. So the depth here is 5 and times 10, 5 times 10, so equals 50. So we divide it by 2, so that's why 25, and then 5 times 5 here is equals to 25, and half of the 25 is 12.5, so we multiply it and subtract it by 25 minus 12.5, and the answer is 156.9 feet squared, and the answer is 5.81 feet if we divide it by if we divide 156.9 feet squared over divided by 27 feet here. So we know that the hydraulic depth here is 5.81 feet. So we solve the letter A now, the hydraulic depth, and let's go to the B, the velocity. We know that the formula of the velocity is V is equals to 1.9 for the English version over N, and the hydraulic radius, the RH, 2/3, and we know the SO, the slope, is 1/2. So here we know that the N is 0.011 and the slope is 0.012, and the missing piece here is the hydraulic radius. So the hydraulic radius, the formula of the hydraulic radius is the area over the weighted perimeter. So the weighted perimeter here is we get it by, we know that here is 2.2. If this is 2.2, so let's begin with this side. So 2.2 and 2.2 plus, we used it the Pythagorean theorem, so the square root of 5 squared plus 10 squared plus 12 the square root of 5, this is the 5 squared, so this is the 10 squared, the base here is 10 squared, so that's why we get this number here, the 5 squared plus 10 squared, so plus 12 and the square root of 5 here, and the 5 squared, square root of 5 squared plus 5 squared plus 22 plus 2.2, so that's why. And then we get the weighted perimeter by 34.64 feet here. Understand, guys? The square root of we use the Pythagorean theorem here, the 5 square root of 5 squared, 5 here, and 10 here, 10, so that's why square root of 5 squared plus 10 squared. So the hydraulic radius here, and we know the area is, where's the area, is 156.9 feet squared. So 156.9 feet squared over 34.64 feet, the weighted perimeter here. So we multiply that numbers, and we get this 4.528 feet. So we can solve the velocity here. So it's 1.49 and the n is 0.11 times the hydraulic radius is 4.528. Here we copy the 2/3 and the slope is 0.02 feet. That's why this is 0.012 feet and 1/2. And then if we divide it and multiply it, and we get this answer 40.6 feet per second. So we solve the velocity now. The velocity is 40.6 feet per second. So letter C, we classify the flow. And so the FROD or the FR is equals to V over square root of GD is equals to the velocity here is the 40.6 feet over per second rather. So 40.6 feet per second divided by square root of 32.2 feet per second squared, and English form, or rather English term is 32.2 feet per second squared, and hydraulic depth here is 5.81 feet. So we get this answer now, the 2.97. You multiply, you divide it 40.6 here. So we classify it by supercritical flow. So thank you guys. Thank you guys for watching. So I hope you understand how I explain this my solutions about open flow and critical flow. So thank you guys.